Hello. Today's training center is about the API. Maybe you didn't know, but xyzt.ai SaaS platform, it also provides a very extensive API. And so the goal of today is really to learn what is possible with the API and also how to get started. I will first talk about some main use cases, why our customers use the API. I'll then show you where to find all the documentation, how to create API keys so you can use it. And then I will go in a very concrete hands-on example, which is, I think, the most common case why people use the API is to automate data uploads in the xyzt.ai platform. But I will also discuss other actions that can be automated using the API, but I will not provide hands-on because it would take us a little bit too much time for this session. I hope by the end of the tutorial, you have a good sense of what is possible, how to get started, and also where to find all the material, and then maybe follow one of the more advanced self-service tutorials. So why do our users use the API? Well, firstly, to connect data. You can connect data to the platform using the web interface just by drag and dropping CSV files or GeoJSON files. But for instance, when you want to automate data uploads, for instance, every day or maybe every minute you have new data, typically people use an API for that. Second use case is to do tasks that if you would do them manually, it would take you too much time. And a typical example is, for instance, you are creating a solution for city authorities, and your solution contains an xyzt.ai dashboard. You don't want to create a dashboard for every single city that you are selling your solution to every time manually. So what our users do is they create a script that defines a dashboard just by calling the API. And by parameterizing the script, you can basically run it for as many cases as you want. For instance, for all cities in the US or for all ports in the world. And I'll give you an example later of that. Third use case is when you want to integrate some of our analytics into another data science workflow, for instance. So for instance, you can think of you want to do some very advanced spatial temporal queries using the xyzt.ai platform, but you want to use the results of those queries into another workflow. For instance, where you then do additional machine learning on the data, or you do additional visualization on the data. So that's another case where people use the API. And then finally, another common case is where people use the API to do certain queries. For instance, queries to know how many ships are waiting in an anchorage zone. And then they get a response from the API, and then they can, for instance, integrate that in an alerting or a monitoring pipeline. Today, I will talk mostly about the first use case, but making the step to the other use cases is quite easy. This is an example, and you can find it in the platform. If you go to the sample projects and you look for the port visibility one, it's an example dashboard that was created using the API. And in fact, this one shows it just for Long Beach in US. But this dashboard was created for every port in the US using just one script where we parameterized the input location and then generated for every port in the US a port visibility dashboard. So you create a script once, but you run it multiple times for many different customers. For those of you who are a little bit unfamiliar with REST APIs, it's very similar to how we browse the internet. And it's in fact almost the same thing. So if you go to our website like www.xyzt.ai, you're basically doing a request to a server, and the server returns you an HTML page that your browser then nicely visualizes. Well, the REST API is similar. You send the request to some endpoints, to some URL. In this case, it's going to be on the API URL, and you get a response. In our case, you don't get an HTML page back, but you get data back, and the data is structured in a format that is called JSON. Most of you will be familiar with that, and I will show some examples also later. So the key idea is that you can ask things, you can also post things. Instead of reading, you can also post things to the API. For instance, if you create a new data set, you have to tell the platform what is the name of the data set. So in that case, you're posting information to the API. And of course, you can delete, and that's typically something people do a lot when they use the API, because they're testing and they're creating data sets and projects and deleting all the time in an automated script. Very similar to browsing, the API will tell you whether it succeeded. So it's quite important, if you code against the API, to look at the response, to look at what you get back. And very similar when you browse to a website that doesn't exist and you get a 404, the API will do exactly the same. So if something doesn't exist, or if your parameters are wrong, or if you didn't authorize yourself, you will get a response with a code that is the same type of code that you get when browsing the internet. Today, we're gonna look into a very small example using the API, and it's gonna be a real-time data upload. So imagine you have a sensor network, and you see it here on the map. All those dots, they're locations of air quality sensors, and they are measuring basically small particle matter, so basically pollution in the air. PM10 and PM2.5 are very common measures taken by air quality sensors, and those sensors, they generate data all the time, and you want to push this data to the platform, not just once, but continuously. And that's where the API, of course, comes in, because you don't want to manually upload files all the time when there's new sensor data. Whether it's sensors with air quality, or whether it's ships moving in a port, or whether it's mobility data with speeds and traffic volumes, it doesn't matter. The concepts are the same, and you should be able to apply what you learned today to your specific use case. So with this sample, I will first navigate to the API documentation. I will create an API user. I will learn how to authenticate with the API. And from that point on, I will basically create a data set. It's called a time series data set in the XYZ.ai platform, because there's data that's varying over time. And doing that data set definition involves a few steps, such as defining what is in the data, then of course uploading the data. If there's time, I will also show how to use the API to then create a project, and then basically create a background layer that is used in the project, and then finally use our newly created and updating data sets in that project. So maybe let's first shift to the platform, and I'll show you where to find all the information. So for that, I'm switching to my browser. You see, I have here an empty account. There's no projects or data sets. I just set it up for the tutorial. The information about the API, it can be found basically here in the top right corner. If you click on the question mark, there's gonna be API documentation. And if you click on that, it will bring you to a different page that summarizes the entire XYZ.ai platform API. The API is structured. So on the left side, you will see that there are different sections. There are sections about data sets, about projects, also about doing queries on the data. So everything is nicely divided there. Today, we will spend most of the time in the datasets section, but the first thing we're gonna do is authenticate ourselves with the API. And to do so, if I click on that, on authentication, you see that it opens up an endpoint, and the endpoint is called /public/API/tokens. And basically, the way that the authentication works is that you first authenticate yourself with a username and a password. You get back a token, and then later on, that token is reused in other API calls to authorize yourself, to say, okay, I am who I am, and I am authorized in this account to add data or to create projects. You see also here, it's a post request. So remember, get, post, delete. And it has a payload, which means that you have to provide data when doing the request. And in this case, you have to provide a username and a password. And that's typically also what you have to do when you have to log into the platform from the website, from the user interface. You have to provide a username and a password. And it's not different here. The only difference is that you have to have an API username. Where to find that? In the top right corner, you click on the little man icon here. You go to user management. And at the bottom of your page, you will see create API user. If you don't see this, or if this is disabled, it means that your account it doesn't have API enabled. In that case, you can reach out to us and see what is possible, because the API usage is an optional package. So the first thing you do is you hit a button, create API user, and you get basically a username and a password. And you will see the username looks like an email address, so it's very similar to your own username, and there's a password to that. Don't worry, I will delete this username and password after the training, so it's you don't have to try using it yourself. But do this in your account, and then take note of these two. So typically what I do is I take a little notepad, or I take a little note and I just copy it in so I don't forget about it. So let me just quickly do that so we don't forget about the username and the password. The reason is you cannot retrieve the password after it was created. So now it's still open, but later on you will see here at the bottom, it will only display the email and not the password credentials. So these two strings, these two pieces of text are what you have to pass into the request. So that's basically what we will have to use to authenticate ourselves. The way you use the API is up to you. You can use it from Python, you can use it from TypeScript, from Java, from any programming language. You can also use it just from Bash using curl. That's up to you. Today I will show it with Python because it's very popular with our customers. But the concepts apply to any other language. So I'm switching to my code editor, which is a Python editor. And I will walk you through this step by step. It will take a little bit of time to get through all the steps, but I will not detail every step, but I will show you the most important ones. So the first one is the URL. This is the API URL. You can also find it in the API documentation. So you see it also here, or if you download the API specification, you will also see the URL. In case you wonder what it looks like, it's always api.platform-xyzt.ai/public/API. So that's always the path that will be followed. And that's why I defined it here like this. So this is a URL we're going to be using for every single call to the API. The username and the password, I already had one created before, so I'll just keep on using that. So this is where you paste in the two strings that you created before by creating that API user. I will also use some data here in this example. They're on my local folder. We can provide you the package with the data. It's open data, so there's nothing secret about it. It consists of the sensors. Where are they positioned in the world? It consists of measurements like over time, what's the air quality at those different locations. And I also have two configuration files, and I'll talk about that later when we talk about the data upload. So what I want to do now is I want to just focus on authentication. And this is basically this little snippet of code here, and it's actually a little bit larger than what I'm showing. So let me expand this as well. is basically the first call to the API. So you see it's a post call. We're doing a post call, and we're basically using the URL that we defined here at the top, and we add a path /tokens. You see we provide JSON payloads, and this is exactly looking like it is documented in the API. So if you go back to the API, you will see that it expects a payload like this, username and password. And if I go back to my code, you will see it's exactly defined like that. So I do a post with this information to the API, just for our information. I print the response. The response contains a status code, and in REST terms, if it's 200, it's successful. So in that case, I can decode the response. I know it's JSON again, so I can ask for the JSON, and then I can extract the token. And this is the token that I will hold. And then later on, we'll pass again to the API calls, so that I can show to the xyzt.ai backend that I am who I am. Those tokens, they are valid for, I think, about 15 minutes, which means that if you use the same token within 10 minutes or so, you can do that. After that, you have to request a new token. This is, of course, for security reasons, that those tokens have a short lifetime. So that is actually the first API call that we're going to be using. It's not the most exciting, I know, but it's important because we need to guarantee that the users of our API, they don't get access to other accounts, or get access when they don't have access, for instance. The next step, of course, is then to create a data set, to define the data set, and to upload the data. For that, I'm going to take a short step back to my slides just to go over the different steps in creating a data set. In the platform, when you work with the web interface, you've been through those steps already, so they will be very familiar. In the API, it's exactly the same. You have to follow different steps to get data in. And the first step is to create an empty data set. When you do that, you have to define the type of the data set. I already mentioned it's going to be a time series data set, so that's going to be the type. The platform supports many, many different types of data sets. So you can do all of that with the API. Another thing you have to provide is the name. What's your data set going to be named like? How are the users of the platform going to see the data, going to discover the data set? Then in the second step, you have to describe what's going to be in the data. Because the platform is agnostic to the type of data. You can have air quality sensors, you can have ships, you can have cars, you can have anything, as long as it's geospatial and temporal, you can put it in the platform. So the first thing we do is we describe and we tell the platform, okay, for this data set, I am going to upload sensor locations. And those sensor locations, they have a property that is called ID. That's the first thing that we're going to do. In this case, the sensor locations don't have additional properties, but you could imagine they have additional properties. For instance, one sensor is an air quality sensor, another sensor is maybe a noise sensor. That could be an additional property, the type of sensor. In this case, it's just the identifier. And this is an important property because we expect it to be there for every type of feature that you would upload to the platform. You also see there's going to be a geometry. In this case, it's just a point sensor, and there's going to be a location, which is, in this case, a longitude and a latitude. This is, by the way, GeoJSON. The platform accepts shape and GeoJSON. GeoJSON is very common and is very easy to work with when you work with APIs. So that's the first thing. We tell the platform what I'm going to upload has a property ID. That's basically the first step. The second step is to actually upload the data. So in the second step, we're going to upload this file, and then the platform checks, okay, does every feature have an ID? And then those features, they are accepted because we told the platform that there's going to be an ID. And then the fourth step is to tell the platform Well, for those sensors, what are we going to measure? What are we going to measure over time? Basically, in this case, we are going to measure PM10 and PM particle matter 2.5. So we have to tell the platform what is in our measurement files. And in fact, I forgot to put in, and I'll just do it quickly now, one of the most important properties, because it is in this file that the temporal data will live. The first file with the geometries is not temporal, it's just static. It tells you, okay, we have sensors there. The second files or type of files we're going to upload are going to contain temporal data. And I just put a snippet here of the CSV file that we're going to use for that to show you what this actually means. So the first column is an identifier. It's again pointing to that same identifier here. We have a timestamp. It's actually a date and a time. And then we have a PM10 value and a PM2.5 value. And for the tutorial now, I don't go into detail about the units of those, but it doesn't matter too much. So that's important that the platform knows beforehand, before you start pushing data to the platform, what's going to be in the data, because the platform does a lot of validation checks on the data that is ingested, and it only accepts data that is conforming to what you specified in this step. And then the final step, of course, is to upload the measurement data. And this is typically where you would take a loop that basically takes the sensor data. If there's new data, pushes it to the platform. Other customers, for instance, they take traffic data every minute or every 5 minutes and push it to a data set so that the analyst or the person who monitors the situation has an up-to-date view all the time. So what I'm going to do now is I'm going to switch back to the platform and to the API documentation. And I'm going to go through these different steps. I'm not going to go and show every single step, but I'm for sure going to show the first, the second, and then maybe the third step. And from that point on, we can advance. So I have the token requests explained, and I'm going to use that in the following steps of the API calls. But let me first go into the first step, creating a data set. And it is almost the same as authentication. The only difference is that I'm using a different endpoint, because it's not the token endpoint, it's going to be the datasets endpoint. And I'm going to provide the token in my authentication header. That's the only difference. And then, of course, the payload, what you provide with the request, the information that you send to the API is, of course, different. But the structure is exactly the same. You see, it's a post request to a certain endpoint with a certain payload, and in this case, also with a header. And the header you see here, it's structured like this. Authorization is the key. And then the bearer is going to be the token that I got from doing the token request beforehand. You see also that I don't keep the token, so I don't store it. So I just do a new request every time. But typically you would store it for 10 minutes or a little under 15 minutes, and then you would reuse it again. The payload looks like this. You see there's a name key. I provide a certain name to my data set. There's a description here, some additional information. There's a type, which I discussed is going to be, in this case, time series data. And then we also provide some additional information on the type of files we're going to upload. So we're going to upload GeoJSON files for the constant data. Constant data in the XYZT platform is called metadata. And we're going to upload CSV files for the time varying data, which is in the platform called data. We can also tell the platform what those dots are, what those features are. And in this case, we just tell the platform they are sensors. If they would have been cars or trucks or vessels, we could have said cars, trucks, or vessels in this case. So the assets, the features, they are in this case sensors. If you do this call, it's going to create a data set on the platform. So let me try to do that And I'm going to shift to the bottom of my script because my script is a bit long, because I wanted to show many different things, but I'm only going to do the first step. So I'm going to uncomment all the other steps that I'm going to show later on. So in this case, I'm not yet going to push data to the platform. I'm not yet going to do any uploads. Let me maybe also disable the final step, which is the loop that senses the measurements and then sends it to the platform. So the only thing I'm going to do is I'm going to create that empty data set. So I'm going to hit run. It's going to evaluate the script. It does some printing for me. You see, I had a successful response on the request of the token, and I had a successful creation of the new data set. You also see here in the success part, I print a body. So basically what I get back from the API, and you see I get back information about the data set that I created. So you see there's quite a bit of information. Maybe what you will recognize is it also sends back the name that was used, which was actually the name that I provided. It has the GeoJSON file as metadata file type and so on. The most important thing for your API use that it sends back is this one, the identifier. Because in the platform, we don't identify datasets by name, because multiple datasets can have the same name. We identify datasets by a unique identifier. And you also see that this method or this function here, it returns the ID. So it basically gets from this body, the response body, the ID, and it returns it when you call create datasets. So if I go back down my scripts, you will see that I keep track of that ID because I'm going to need it later on when I define what's going to be in the data. If I shift to the platform now, there should now be a data set. And actually, before I had some runs already, but it's this last data set. So let me maybe delete the other ones so they're not in the way and we don't make mistakes. This is the data set that was created. You also see 0 file uploads, no data uploads. So it's an empty data set. There's not much you can do besides, for instance, you could go in and change the name of the data set and the description, but that's about it what you can do now. You see here also the second step is to configure the geometry properties, and that's exactly what we're gonna do. You could do it manually in the UI here, for instance, but of course that defeats the purpose of using the API. So I'm going to show you how to do that in the API. And that's actually the second step that I want to do. So I'm going to enable it already. And I'm going to go back to the top, close my create dataset, and then go to the define geometry properties. Before going into the geometry properties, I think I see some of you wondering, how do you know that you have to provide this information? How do you know that you have to provide a name and a description? Well, that's of course in the documentation. So if you go back to the documentation and I go to the dataset section, I can see that there are different endpoints. For instance, to create a dataset, but also to delete a dataset. If I click on create a dataset, it will tell me what properties are allowed. And also it will tell me what is required. And required you see here in red. For instance, a description is required, a name is required, and a type is required. And here you, for instance, see time series data. And there's, of course, many more properties for some types of data sets that are relevant. And there's documentation on when they are relevant and why you should use them or not use them. You will also see an example here in the payload area. It's a computer-generated example, so it's generated from the API definition. So it doesn't always make sense if you look at the combination of things configured, but it is always a valid example. It will also show you what the response will look like. So this is useful when you have to get out of the response what you want to have. And in this case, you will, for instance, see that the ID is a key in the response. So you can use that. So this is how you see from the API what you can use and how you can use it. So that was creating a data set. Second step was telling the platform that in my geometries, there's going to be an ID property. And for that, the platform has an endpoint, and it's called geometry structure, which you can upload a configuration file. In this example, and I go back to the slides maybe for that, the only property in the data is ID, and it's very trivial. In many, many examples, there are tens or even hundreds of properties with the geometries. And so people use configuration files for that. I'm not going to show you how to create those configuration files manually, but you can create them in the platform by doing the manual steps and then by downloading the configuration file. I'll show you what the configuration file for this data set looks like, and it comes with the example package. It lives in geometry-properties.csv, and it's just a one-liner. It's just a one-liner that tells there's an ID property, and the property is a string, it's not a number. So basically, that's what it tells. I would refer to the documentation to go into full detail of how the syntax is of the configuration file, but in essence, it's a CSV file where for every property that you want to use, there's going to be a line that enables that property and configures that property. And so the second step, this step here, the second step is going to involve to upload that configuration file. So in my Python script, you will see that it just does that. It basically takes the file, it does that on this line, and then it passes that to the endpoint. And again, it checks, is it successful or not? If it's not successful, it will return a different code. Otherwise, it will just return normally. This function doesn't return any values. It just continues after being called. So you will see that in this case, it's just a call to define the geometry properties. What you will notice when I run my script again, it will also run this call, and you'll see it's output successful. In the platform, you will see that there will be a second data set now. So this was the one that I created before. This is the one that I created just now, so like 7 minutes later. If you want to just update the data set that you already had, you have to reuse the identifier that you got back from the first call. Another way is to query the data sets, and then to do it, for instance, by looking at the names and then taking the one that you know is your data set. But typically what people do is they keep track of the identifiers. If you wonder where to find the identifier in the front end, it's quite easy. You just click on the data set. You go to, for instance, upload geometry, and it will give you the identifier also here at the bottom. You will also see it here at the top in the URL, but it's also here advertised explicitly for use with the API. You also see now that I opened the dataset, it jumps to step 3, and it means that step 2 is completed, and that's actually the case. You see here the ID property with the display name ID, type string, and so on is configured. So this is the second step that was completed. The following steps are very similar. Uploading the geometry, it's gonna basically upload the GeoJSON file. Configuring the data properties, it's gonna configure the properties, the measurement properties, and then it's gonna upload the data. So what I'm gonna do now is I'm gonna just let the script run up to configuring the data properties. So, oops, and I needed my Python IDE here. So I'll just enable those next steps, which is upload GeoJSON file and then define the data properties. If I run this one again, you will see it take a little bit longer. But again, all those calls were successful. I get a new data set. So I'll delete my old one. And you can see now that in the geometry part, there's data uploaded. The sensors.geojson are there, and they're already processed. You see, so the platform already went through the data. And it found 100 sensors. So there are 100 sensors in this data set. You also see that measurement values are configured. The platform knows that it expects now ID time PM10, PM2.5 values in the CSV files. The only thing that's missing is the data. And you see no files uploaded, so no data pushed to the platform. And that's what I'm going to do next. It's basically pushing sensor data or measurement data to the platform. And just to show you what I did here, I'm not using a real-time feed. I'm using sort of a simulator. So I have a folder with measurements, and it's basically looking like this. It has 1,000 CSV files. So imagine every CSV file corresponds to a measurement of all those sensors every 5 seconds. So if you look at what's in the file, it's exactly what was on the slide. There's a sensor ID, there's a timestamp, and there's a two values. And in this case, the files contain about, I don't know, 50 measurement values. So not necessarily for every sensor in this case. So it's more like a log of a real-time case. To show you how to get the data in, it's again very similar. I go down in my script, and to simulate a real-time continuous loop, I basically created a for loop here, and I'll uncomment it, which just runs through those 1,000 files. You see here where the file is picked up. It uploads the file, and then it sleeps for 10 seconds. And maybe for the tutorial now, I'll change it to 5 seconds, so we have a little bit more files being pushed to the platform. Important to note here is you can leave all the files in the platform, so you can push data, and then you get real-time data with historical information, which makes that you can go back and see, okay, what happened yesterday or the day before. In case you don't want to keep the data and you're just interested in the last information, you can just remove the data that was pushed previously. And the script shows you how to do that. In this case, it's not deleting every other file. So if you push a file, you delete the previous one. In this case, it's going to keep the, I think, 20 most recent files, and it's going to start only deleting files after there are 20 files in the platform. And the reason here is that not all sensors send out information in every batch. So we like to keep a little bit more information. You can keep files for like a day or just 10 minutes. It depends on the use case. We have customers that keep data a day and only delete when the new day is in the platform. We also have customers that keep data for a week, and then they only start deleting all data that is older than a week. The way that the platform deals with this is as follows, and it's quite easy. You define an identifier, just a string, just some piece of text that defines to which batch a certain file belongs. And if you then want to delete all the files belonging to the same batch, you just do an API call that is similar to the ones that I showed. So that's what the loop is going to do. And if I run it, you will see at some point it's going to end up in this for loop. And you see what it pushed. So it pushed time 0.csv in batch 0. The next file also in batch 0. So you can have multiple files with the same batch identifier. It keeps doing that. It sleeps for 5 seconds. It pushes the other files. And from now, we're basically having data in the platform through the API. So if I go back to my data sets, let me delete my old data set. You will see that it has more than the 100 sensor values or sensor location values already in the platform. So you see that these things are updated. You will also see that the state of the data set changes all the time, because every 5 seconds, there's going to be new data to be processed or to be looked at. What does this data set look like? Well, there's one way to look at it. So you just create a project. I call it like this, my sensor project. You go to your data set, you attach the data to the data set. I'm also going to add a background layer to get some context information. And then I can go to the visual analytics and I see my sensors. So I see the locations where they are, but I also already see that there's temporal data. And this temporal data is actually the data that is pushed in the loop, coming from those CSV files. You should also see that once in a while, the platform will update and it will show you new data. By default, the platform fits the time range on the full time range when you open this page. So you see that the time range here at the bottom is fixed and there has been new data added beyond the time when I was opening it. If you always want to look at the last data, you can do that by right-clicking on the map and you can say, for instance, log on last hour. And in that case, it shows you the last hour of data. So you see it happening here. There's now 1 hour of data that we are looking at, and there's older data that is kept. The older data will slowly disappear. So, for instance, we still have data a little bit after 2 p.m. until 3 p.m., but this data will soon disappear once the loop continues and there's more data being pushed to the platform. So that's what every 10th file, it looks at deleting the 10 oldest files. So it does that not continuously, but only every 10 files. This type of time filter is very common when you work with real-time data because you always want typically to look at the last state. And to give you a use case example of that, for instance, you can look at, if you're interested in how many sensors have a certain PM10 value above a threshold. So where is the air quality bad? How many locations? So what you do then is you set a filter, a basic filter on PM10. And for instance, you say, I want to see where it's above 20. In this case, by coincidence, it's 20 sensors. It's pure coincidence. So let me maybe take a different value here. Say, okay, where is it above 30? And in this case, you see it here on the map. And this allows us to, for instance, put widgets that monitor this. So for instance, I can add this as a widget, number of sensors with PM10 above 30. And I can add it in my demo group. And if I go to my demo group, on the dashboard here, it now has a real-time widget that updates whenever there's new data in the platform. And the reason is that I use this temporal filter on the timeline that sort of always looks at the last hour. You can do the same with the map. So for instance, I could do the same with the map, add it as a widget. And it's going to show the same thing. So it's going to basically show you for those 18 sensors where they are on the map. So this way you can build a dashboard that is not only showing historical data, but also real-time updating data. I believe our dashboards, they refresh every 5 seconds. So depending on how fast the data flows in and how fast the data is processed, how fast you will get an update on the dashboard. But typically, if your size is not too huge, it will be almost instantly. So that's the data upload part. Of course, the API can be used for much, much more. And in fact, let me maybe stop my script here because I'm going to run it again later with a different example. So let me maybe delete this project, and I'll also delete the data, and I'll run the script again in a second. So this is data set creation and data upload, and you've seen it here under the dataset section. There's much more. You can create projects, you can populate projects with data sets, with background layers, and you can create dashboards, as I mentioned. So I'm going to show you how that looks like without going into too much detail. So I'm not going to focus anymore on this loop. It's going to run the loop that uploads data continuously. But I'm going to focus on the next parts. And for instance, there's API calls to create a project. There's API calls to create a Mapbox background layer. There's API calls to use them in a certain project. So the sample data provides that information, and you can look it up. But it's actually very simple. It's again a post call on a certain project, on the data sets, and you provide basically the dataset ID. So very similar calls as before. And when I run this, it will not only do the dataset creation and upload, it will also create a project, attach the datasets, attach the background layers. And I can go even further. I can do what I did manually. I can create a dashboard with the API. For instance, I can create a widget group. So widgets can be grouped together in different groups. I just create one with the demo name. And you can, of course, create any type of widget on the platform using the API. I have a small example here in the project. I'm just going to focus on this first. So I can provide a title to the widget, a description. I can say it has to be 12 columns wide, 4 rows height. I can define what should it show. It should show a map, a spatial map. It should show just one in this case. I can show also side-by-side comparisons if I want. I can provide a time range. I can provide a bounds to look at. And in this case, you will see that I defined the time range here before. And it's the same time range as I had in my previous example. It's just looking at the last hour. So this is how you define that. It's a relative temporal range. And then, of course, you can define all types of styling properties. And all of these are, of course, documented in the API. In this case, I'm just going to use a heat map by number of records and coloring it as a rainbow color map. And yeah, that's about it. So if I run this script again, it will do all these steps for me. So there's no single manual step involved anymore. The only manual step that you had to do was getting the API user credentials. And from that point on, it runs automatically. So if I go to my dashboard again, you will see now that there's a project. So the project was created. The project has a data set. It has a background layer. You see it's the light Mapbox background layer. It is there. It has a data set, and it's the data set that I created similar as before. It's of course a new data set because it's just been created. It's still queued for processing, so most likely there's a machine firing up now to accept the real-time data, and once the machine is running, it's gonna update continuously. And as soon as I have some data processed, I will be able to open the visual analytics page. I will be able to open the dashboard, but for now, I have to wait until the first data is picked up and processed. Why does this take a little bit longer than before? Before there was probably a machine running already to do that, and the machine said, okay, I have a new job to process. In this case, probably the machine is not running anymore and it's firing up. And once it's fired up, it will start processing the data. And then as soon as you keep pushing data to the platform, the machine will be running and accepting the data. So you'll see now some records are processed, so I can go to the visual analytics page and I can go to the dashboard page, which just shows the rainbow color map by number of records. So this is how you use the API. So you use your favorite coding language, and you can script dataset creation, dataset uploads, you can script project creation, and even do dashboard creation. One topic, unfortunately, I don't have time for that anymore, is you can also use the API to do queries on the platform. For instance, you can do queries like, give me all ships in a certain area, or give me all the sensors that have a threshold PM10 value above 20 or 30. Give me a histogram, a timeline, all the different analytics you can do in the platform, you can query with the API. What's next? Well, we do have tutorials in the platform, very similar to what I gave. There's one difference though, and I didn't go into details today, but if you go back to the API documentation, you will see that at the top, you will see that it's an open API specification. And an open API specification means that it follows a certain structure so that machines and also humans can understand the API. And for instance, this documentation that you see, it's fully created automatically from that specification. And that's a big advantage when software provides an API in the open API specification. A second advantage is that you can do build code tooling around the API. And there's a lot of open source code tooling that allows you to work with an open API, very similar as working with an SDK, with a software development kit. And the tutorial goes into that detail about how to generate a software development kit for the API, and then just use the API as if you would be doing coding instead of doing web calls, REST calls. So that's what's in the tutorial. So it goes one step further to what I explained today. So you can find the tutorials here, and you'll see that there's one for Python, I think, and one for TypeScript, but feel free to use your favorite coding language. So before I look into whether there are questions, let me summarize what we learned today. The API is really, really powerful, and it's really how our power users exploit the platform for their customers. That's typically the main use case, to connect real-time data, to connect batch uploads every night, to define dashboards that they can deploy for any city, port, or road authority in the world, to integrate analytics in their workflows, to build monitoring pipelines, and so on. We provide a full REST API, so it's beyond data uploads. We've talked about project creation, we've shown dashboard creation, very simple one, but you can also do querying. We also keep the API backwards compatible, and if we do change things, we make sure that the previous version keeps working. We do advertise which are the duplicate API endpoints, so you don't start using them in your new projects. But in any case, we try to make it backwards compatible because we know that our customers have running scripts that need to keep working. The main URLs are summarized here, so if you want to look them up later, so there's the API documentation itself, there's the user management where you create the API credentials, and then there's, of course, tutorials as well. And we talked about the Open API compliant API. And if you're interested, have a look at the tutorial. It exploits that fact. So let me check if there are questions. Feel free to put them in the chat. I think we have a few more minutes. I know it was a long session, but we had to go in quite a bit of material here. Okay, I see a question. Can the API reuse data published within the XYZT platform itself? Good question. The answer is yes, and I'll show you what that means. So for instance, if you would go to the datasets page, you will see I have my own dataset now that is now constantly updating. All the datasets that you see, even the sample datasets, you can query by API, and you can attach them to your own projects. Very similar as you can do by clicking. So, for instance, by clicking, you can also do your own project, go to the sample datasets and attach them to your own project, and then look at those datasets. You can do that with the sample datasets with API. You will get, if you do the query through the datasets query, there's a datasets query, this one, retrieve all available datasets. It will give you back an array. So this is an array, and every element in the array has an object that gives you the ID, the name, and so on. And for instance, if it's a sample data set, the owned flag will be false, and then you can use that data set. So with that, I think I'll follow up with the other questions through email, but we're nearing the end of the hour, so I don't want to keep you from your other work. So thanks a lot for attending. If you start using the API, if you have troubles, don't hesitate to reach out. Typically, we can help you further very quickly. And if not, good luck, and hope to see you soon in one of the other training sessions. Thank you.